and nobody wants that. So, okay. So now we're live. So, despite how we use this language in day-to-day life, when we speak mathematically, odds are different than probability. They don't mean the same thing. And this can lead to lots of confusion, all right? Because there are two main places where we use odds. The first is betting, all right? If you go to the 40-degree racetrack, or if you go to a casino, or if you go to Vegas, they will express things as odds. Or these people who gamble online on things, like you could go online today and place a bet on who the next Prime Minister of Canada will be, and they'll tell you the odds of that happening. Hint, it's going to be Trudeau. Anyway, you can pretty much take that to the bank, whether you like it or hate it. That's probably where it's going. But anyway, but unlike probability, it uses a different formula. Don't write this, all right? Don't write this. I'm just going to remind you. When we said probability, we said the probability of something was equal to the number of events you're interested in, right? Divided by the outcome. Yep. Divided by the total, divided by all the outcomes, right? So if there's 8 ways something could happen and 2 of them were what you're interested in, it would be 2 out of 8, right? Does that make sense? That is not how odds are calculated. Odds are calculated thusly. The odds equal, yes, this you write. Number of outcomes of interest, so what you want to happen, or what you're looking at, divided by okay. I have tried to do a few things to draw attention to a keyword up there.
Really? A keyword outcome?
Correct. That's very good. Very good. Now, other. This is key. Instead of dividing the things we're interested by all the outcomes, the odds divides the things we're interested in by the things we're not interested in. Now, this gets a lot easier if we look at an example. Okay. So let's talk about what are the odds of rolling a 3 on a 6-sided die? Well, if we roll that die, we can get 1, 2, 3, 4, 5, or 6. Obviously, how many of those are actually of interest to us? Yep, just this guy here, right? So the odds would be this. On the top, we would have 1, because that is the outcome we're interested in. But what number goes on the bottom? No, 6 would be the total. 5, very good. Because 5 are all the other outcomes. Yeah, it's weird, right? It's weird.
Well, if you take out the outcome.
That's right. So you remove the one that you want. So on the top goes the ones that you want. On all the bottoms on the bottom goes the ones that you don't want. Yeah. And of course, we could also express this as a decimal. I will note that we usually do not express odds as percentages. We express odds as fractions or as decimals, but not as percentages. Having said that, what would this be as a decimal? .1 divided by 5?
Looks like Amy's got it.
Amy's got it. Amy, what do we get?
2.
Perfect. Okay, 0.2. And sorry, I'm going to move this word outcomes because I'm going to show you one other way we show it. It's okay. It's okay. It's okay. I'm sorry. I should have. That's my fault. I accept full responsibility. There is one other way we show it. Sometimes we say it as 1 to 5 odds. All right. I don't like it as ratios, but we do see it that way sometimes. So again, we always do the interest first and all others second. So we sometimes see it expressed that way. In math class, I will not use the one on the right because it's not easy to work with mathematically, right? So we tend to stick to the ones on the left, but you will sometimes see on a booking site something like that, 1 to 5. Keep in mind, this does not mean 1 out of 5. It means there's one way that we can get what we want for every 5 ways that we get what we don't want. That's what odds mean. And if you learn nothing else today, that's the big takeaway. When we look at odds as a fraction or like this, it's not out of total, it's a ratio. In this case, one way to get what I want on the dice for every 5 ways to get what I don't want. Okay. Yeah, so let's look at the next one. What are the odds of rolling a sum of 8 when rolling 2 6-sided dice? Well, I don't want to sit here and work out all those probabilities again. Can we go back and look at lesson 2.2? Do you remember we did this? Now, I never filled mine out. Whoops. But I think this was 3 out of 36. This one should have been 4 out of 36. This one should have been, yeah, this one should have been. And then what happens? No.
5, 4. Oh, yeah.
Yeah, 5, 4, 3, 2, and 1. Now, obviously, could I put all of those in lower terms, or a lot of those in lower terms? Sure, but let's ignore that for a second. What does the question I've just asked me for? It says, what are the odds of rolling a sum of 8? So let's go back to that lesson then. How many different ways could I roll an 8? 5. So there's 5 ways. And how many ways are there total to roll 2 dice? Good. So let's take a look at this. So there's 5 ways to roll 8. There's 36 ways total. So the odds, less common 1D spelling of odds. Whoops. The odds in this case would be what? How many ways can we get what we want? Very good. So it's 5 ways to get what we want for every 31 ways to get what we don't want. So 5 ways to roll an 8 for every 31 ways to roll. Oh, I need to put that number. Ways to roll Now, this is actually pretty straightforward, right? It's not earth-shattering stuff, but just be aware that it takes some getting used to. What would this be as a decimal, by the way? Can somebody do this on the calculator for me? I'm not trying to be difficult, but I don't have a calculator, so I can't. Oh, I do, yeah, please. I can tell you that's going to be like, oh gosh, 1 out of 6, so roughly like 17, 16%, maybe 15.8, 16 point something.
It is 1, 6.
What is it?
0.16. Okay, so 16.
So that's pretty good. That's pretty good. I'm almost starting to think I'm qualified for this job. Full disclosure, I'm not.
Almost.
One of these days, one day. if I study really hard? How we doing? Did you have this down? Did you get the same answer? Are you sure? Have you looked at my board? Okay. I'm glad we had this talk. Okay. I want you to try the next one. So let's imagine that you've already got this in your hand. You're at the poker table. You, of course, are over the age of 18. So you're legally at the poker table. And you've got an ace of hearts and a king of clubs in your hand, and you're waiting for another card. What are the odds that your next card is an ace? What are the odds that your next card gives you a pair? All right, so take a minute and work it out. So take a couple of minutes. I'll walk around and ask you how you're doing. That's how I feel. I slept like a baby last night, and I feel like a wreck. I've been making really goofy mistakes all day. I mean, I make really goofy mistakes all day. Maybe the difference is I'm old enough to notice. Maybe every other day I make just as many mistakes. Yeah. Yeah, beautiful. And what about this one? That's exactly right. Oh, I like your thinking, but how many other aces are there? Just one. Just one. But the thinking is spot on. It's not just one. Yeah. I like that. This number. This is.
Oh yeah.
This is like after this one.
Okay. Okay. So this. Okay. Nope.
Close. Definitely three. I like those there. Why don't I? Let's think. How many cards are in the deck to begin with? Now, how many cards are in the deck for giving you 50. Okay, perfect. There's 50 cards there. How many of them work for you?
So what if we?
Yes. Because remember, odds is always on top, the ways that work for us. And on the bottom is the total. The bottom is the ways that don't. That means for every 3 cards that work, there are 47.